Hello guys, my name is Engineer Incredible and welcome to my YouTube channel. So today I would be solving past questions of Maths 103 from the 200 to from the 2016 to 2017 session. So first of all, the first question in the particular PDF is given that f of x is equals to x squared minus 1 and g of x is equals to 3x plus 5. Find g of f of x and f of g of 2. Now, these are two typical questions, and here is how you are going to solve it. So, first of all, when they tell us to find for g of f of x, is mostly written in this particular way. It's written as g of f of x inside brackets, this particular way. Now, when we write it in this particular form, we are going to look for our f of x in order to be able to put it into the g of x. Now, our f of x here is equals to x squared minus 1. So therefore, g of f of x is equals to g of x squared minus 1. So in function, wherever you have something like f of x is equals to x squared plus 2, for example, and they give you something like find for f of 2, that means wherever you see x, you have to put 2, you understand. So in this particular case, they ask us to find for g of f of x, which is supposed to be g of x, and the f of x is equal to x squared minus 1. So that means they are trying to tell us to find for g of x squared minus 1. That means wherever we see x in the g equation, we are going to be putting x squared minus 1, where the g of x here is equals to 3x plus 5. Yeah, that means g of f of x will be equals to 3 in brackets x squared minus 1 close brackets plus 5. So from here we simplify it, we get it as 3x squared minus 3 plus 5, and the final answer will be 3x squared minus 3 plus 5 will get plus 2. This is the final answer to the question finding for g of f of x. So now we will be moving on to the next question, which is finding for g of f of 2. So in this particular scenario, we have to find for g of 2, then we find for g of f of 2. So you remember when I said f o g 2 is mostly written, it will be written as f of g of 2, of g of 2, this particular way. So in this particular case, we are going to be having something similar but different. Here we'll be looking for our g of 2. Now, what is our g of x here? What is our g of x right here? We have our g of x is equals to 3x plus 5. Our g of x is 3x plus 5. So that means our g of 2 is equals to 3 times 2 plus 5. So the total answer will be equals to 11 for g of 2. Will be equals to 11. So then what is our f of g of 2? That means f in bracket g of 2 will be equals to f in brackets 11. So that means if f of x is equal to x square minus 1, that means f of 11 is equals to 11 square minus 1, which is equals to 121 minus 1. That means the total answer is equals to 120. So that is the answer for f of g of 2. So now the number 1b of the maths 2016-2017 past question states that observe the derivative of 5x squared plus x minus 2 using the first principle. So we are going to be solving this derivative right here using the first principle. So we have here y is equals to 5x squared plus x minus 2. That means if we are going to be solving this using the first principle, wherever you see y, you are putting y plus delta y, and wherever you are seeing x, you are putting x plus delta x. So that means here we will have y plus delta y is equals to 5 x square. Here we are going to be putting x plus delta x, replacing x. So that means it will be in a bracket. This way we have x plus delta x, close the brackets, then we put our square. So then in this particular place here, x here will be replacing it also as x plus delta x. Then here we have our minus 2. So from here we are going to simplify it. When we simplify it, we get y plus delta y is equal to 5 open brackets. When you are expanding these brackets, if we try to expand using the binomial theorem, we are going to get x squared plus 2x delta x plus delta x squared, close brackets. That is the expansion of this. Then we have here plus x plus delta x minus 2. So we can continue here as y plus delta y is equals to, when 5 multiplies everything in the brackets, we have 5x squared plus 2x delta x plus we have 5x squared plus 5 times this, we have 10x delta x plus 5 times this last one here, we have 5 delta x squared. Then we have our plus x plus delta x minus 2. So now after simplifying it, what we are going to do next is that we are going to be making delta y the subject of the formula. So we have delta y is equals to 5x squared plus 10x delta x plus 5 delta x squared plus x plus delta x minus 2. Then when y comes to the other side, it changes sign. We have minus y. Now getting to this place is where this equation goes tricky. So right here we are going to be replacing y in this particular part of the equation with the initial equation, which is y is equal to 5x squared plus x minus 2 again. So therefore we will have delta y is equals to 5x squared from here plus 10x delta x plus 5 delta x square. We have plus x plus delta x. We have minus 2. Then we have minus, or let me put it somewhere down here. We have minus, in brackets, 5x square plus x minus 2. So what we are going to do here, we open these brackets. We have delta y is equals to 5x squared plus 10x delta x plus 5 delta x squared plus x plus delta x minus 2 minus, we have minus 5x squared. The minus will also reflect here. We have minus x, then minus times minus 2. Minus times minus will give us plus. We have plus 2. So from here, we have minus 5x and we have plus 5x here. So minus 5x here, we will remove plus 5x. Minus x here, we remove plus x here. Then we have plus 2 here, we remove minus 2 here. So after this, our equation is simplified. We have it as our equation as delta y is equal to 10x delta x plus 5 delta x squared plus delta x, nothing else. So this is the equation right here. So for the final step of this, or not the final but almost the final, for almost the final step of this, we are going to be dividing everything in this particular equation by delta x. So we have delta y divided by delta x. We have this also divided by delta x. This one also divided by delta x. And this one also divided by delta x. So right here, we'll be simplifying. Delta x here will cancel delta x here. Delta x here will cancel one of the delta x. It will remain 1, which is only delta x. Delta x here will also cancel delta x here. So what we'll be having is delta y over equal to we have 1. So from this place, now we know that dy dx is equals to delta y over delta x, where delta x so that means dy dx is equal to 10x plus 5 times 0 plus 1, which will be equals to 10x plus 0 plus 1, which will be equals to 10x plus 1. Now this is how to differentiate using the first principle. So now in the question 1c, they ask us to determine the integral 4x plus 2 raised to power 4. They ask us to integrate this question. So if we are going to be integrating it, here is how we are going to be doing it. We are going to be picking this right here and replacing it with an integer, and mostly we usually represent it with u. So we put our u is equals to 4x plus 2. That is what we get for the value of u. So after getting this, we'll find for du with respect to x. So it will be du dx. We have our du dx is equals to du dx of 4x plus 2. What will it give us? It will give us 4 in differentiation. Then after this, we are going to make the x the subject of formula. How do we do that? We first cross multiply. We have du is equals to 4 dx. Then you divide both sides by 4. So 4 cancel 4 here. Then we have dx is equals to du over 4. That means dx is equals to 1 over 4 times du. So after this, we'll come back to our equation that we are given earlier here. They give us to integrate this. So we have integral sign. Now we said u is equals to 4x plus 2. That means 4x plus 2 here, we will change it to u. So we have u raised to power 4. And in the other place where we see dx, we are going to be replacing it with 1 over 4 du. So that is times 1 over 4 du. So when we are integrating it, 1 over 4 here is a constant, so it will go out of the integral sign. So this is going to lead us to 1 over 4 integral sign u raised to power 4 du. So right here we are going to be integrating u raised to power 4. Now for those that are not familiar with integration, here is how you integrate. Imagine we are given something like x raised to power n. Then we are asked to integrate x raised to power n dx. Then this is how we are going to be integrating it. We are going to be doing it this way. P is equals to x raised to power n plus 1 divided by n plus 1. So that is how to integrate. So that same thing is what we are going to be doing here. The same thing is what we are going to be doing for u raised to power 4. This will be equal to u raised to power 4 plus 1 all over 4 plus 1. That is this particular u raised to power 4. So then we'll put our 1 over 4 that is outside here. 1 over 4, put this one in brackets like this. This is the way that it's going to be. So we'll have this equals to 1 over 4 times u raised to power 4 plus 1, that is u raised to power 5 all over 5. When we multiply this together, we will get u raised to power 5 all over 20. Now, what is the value for u? We have written our u as 4x plus 2, so we'll bring it back to 4x plus 2. So now this final answer is equals to 1 over 20 times 4x plus 2 raised to power 5. Now this is our final answer. So right here now, in the 2a of the question, or the past question, we have obtained the following limits. Limitation x tends to 0 of 3x squared plus 2x squared plus 4 all over 4x cubed plus 8. And in the second one, we have limitation x tends to 0, x minus 1 over x squared minus 1. Now, how are we going to solve these limits? Normally, if you are given let us say limitation x tends to 2 of a particular equation like x plus 2, what you are just going to be doing direct, you are putting 2 here, then you get 2 plus 2. But in this particular scenario, you cannot have it like that, because if we put infinity into any one here, let's take the first one and we put infinity there, we have 3 times infinity square plus 2 times infinity square plus 4 all over 4 times infinity cube plus 8. We will be getting indefinite answers, and we do not want an indefinite answer. We want our answers to be definite. So how we are going to solve this is by using the L'Hospital's rule. So when we are using the L'Hospital's rule, we are going to be doing it this way, where we have 3x squared plus 2x plus 4. If we are going to be solving the L'Hospital's rule, we are going to be doing it this way. We are going to be finding for the value of x with the highest power. So the value of x here with the highest power in I here is what? We have x squared, we have x squared, we have x cube. That means x cube is the one with the highest power. So we are going to be dividing every single component of this equation with x cube. What we are going to be doing is 3x squared divided by x cube plus 2x squared divided by x cube plus 4 divided by x cube. So we have 4x cube plus 8 divided by x cube divided by x cube. So from here, what we are going to be doing is that we are going to be simplifying it. We have x here, it will remain 1x here, then this one too the same, here nothing goes, then here x cube will cancel x cube, here x cube stays. So we are having 3 all over x plus 2 all over x plus 4 all over x cube divided by 4 plus 8 over x cube. Now, from this particular place, you have to note something, which is that anything divided by infinity is equal to 0. But first of all, from this x, we are coming back to our limit, which is limitation x tends to 0. So if you are putting limitation x tends to 0, that means anywhere we see x, we are putting infinity there. So how will we solve this? We have it as 3 over infinity plus 2 over infinity plus 4 over infinity cube all over 4 plus 8 over infinity cube. So now this is what it is going to become after bringing out the limits. So now I say that anything here divided by infinity is equals to 0, and anything divided by 0 is equals to infinity. You have to take note of this when you are doing limits, because it's part of the basic rule most of the rules that you are using in limits. So from this particular case here, we have 3 divided by infinity, we have 0, plus 2 divided by infinity, 0, 4 divided by infinity cube, 0, all over 4, plus 8 divided by infinity cube, we have 0. So the total here, we have 0 plus 0 plus 0, 0, 4 plus 0, 4. We have 0 divided by 4, and our final answer, 0 divided by 4, is equals to 0. Now, do not make a mistake for 0 divided by 4 equals to infinity. Is when it is something like 4 divided by 0 that we have infinity. But when it's 0 divided by 4, it is still 0. So now I'm moving to the second part here, and the second part as it is viewed is the exact same way we are going to be solving it, which is still the El Hospital's rule. So you know what to do here. We find for the value of x with the highest power, which is x square, and divide every single component by x square. So we have x over x square minus 1 over x square divided by x square over x square minus 1. Then simplify it here. We have only one x goes here, remain one x. Then nothing goes here. This one cancels this one. We have 1 over x minus 1 over x square all over 1. No, this is supposed to be 1 over x square. Sorry. So we have 1 minus 1 over x square. So from here we do our limits. Wherever we see x, we put infinity. We have something like 1 over infinity minus 1 over infinity square all over 1. Yes, 1 minus 1 over infinity square. So when we get this, and the same law that we use, anything divided by infinity is equals to 0. Any- Anything divided by infinity is equals to 0. We will be getting 1 divided by infinity, that is 0. 1 divided by infinity square is 0 all over 1 minus 1 over infinity square 0. So we are having 0 divided by 1, which is going to give us 0. So our final answer for the second one is equals to 0. So now in the question 2b, we were told to find for the integral of x squared times e raised to power 5x. Now in this particular case, we are not going to be doing normal integration. We are going to be using integration by parts, in which a lot of people find as a problem. So I'll be trying my best to be explaining it in a way that is much more easier to understand. So now the formula for integration by parts is u dv is equals to uv minus integral v du. Now this is the formula for integration by parts, in which we are going to be using here. So we are going to be picking this as u, and we are going to be picking our this as dv. So we will pick something like this. We have u is equals to um, we are going to be having our u is equals to x squared. Then we are going to be having our dv here as e raised power 5x. So after this, we are going to be solving it this way, finding for dv, and we are going to be finding for u. So we have our u du, that is du dx, normal differentiation. This will become 2x, and if we are integrating this, we are going to be having u as 1 over 5 times e raised power 5x. So after we have gotten this, we are going to be imputing it into our formula, which is the formula for integration by parts here. So we have our u dv, this is u and dv, which is e x squared times e raised power 5x, is equals to u times v, which is equals to x squared times our v here. This is our v, which is our x squared times 1 over 5 e raised to power 5x then minus integral v du. Now our v here is 1 over 5 e raised to power 5x, and our du is equals to 2x times 2x. So in this place we have 2 and 1 over 5 as constant, so they will come out of the integral sign. So we are going to be having this as x squared and 1 over 5 x squared times e raised to power 5x minus the 2 and 1 over 5, that is minus 2 over 5. We put our integral sign x times e raised to power 5x. So from here again we have to integrate this, and the main problem here is that for us to integrate this we still have to use integration by parts again to integrate this part for the second time. We have to make sure that the total integration is going to give us something else. So for us to integrate it, so now for us to integrate this, I'm bringing this one out here. I have x times e raised to power 5x. So for us to integrate this dx, this will be u and this will be du. We'll put our u as u is equals to x, and our dv is equals to e raised to power 5x. And our du here is equals to 1, then our v is equal to 1 over 5 times e raised to power 5x. So from here we can continue to integrate this. We can continue to integrate this part of the equation. We are going to be having u dv is equals to u times v, which is u here, x times, what is our v, 1 over 5 times e raised to power 5x times v du. We have minus integral sign v du, which is 1 over 5 times e raised to power 5x times, what is our du? Our du is equals to 1. So 1 divided by everything will still give us the same thing. So now from here we are going to be getting this particular place does not need the integration by part anymore, so we are not going to be breaking it down more. We are just going to continue with our integral. Let's not forget the dx size here. So when we integrate this, we have e is equals to 1 over 5 times x e raised to power 5x minus 1 over 5 times, when you integrate e raised to power 5x, we still have 1 over 5, we have times again 1 over 5 times e raised to power 5x. That is after integrating this equation. You know, the way of integrating e is different from the way of integrating normal one. So then when we have this, we are going to bring it back into this our equation here, because this is only an integration for this part here. So we are going to be having it as the part as equals to 1 over 5 x squared times e raised to power 5x minus 2 over 5 in brackets. Now the integral of what we got here, the integral of this is what we are now going to be writing in this place, which is 1 over 5 x times e raised to power 5x minus 1 over 5 times 5, that is 1 over 5 times